Okay, this is, what lesson is this? 3.2? So this is lesson 3.2, page 139. Okay, number 2. Let's go through this. We're relating standard to factored form. And what that essentially is take an equation in standard form and factoring it. That's all it is. But what we want to do is we want to talk about what the factored form does for us. How does this help us solve anything when we're graphing or when we're trying to find answers, okay? So the very first thing we're going to do is we're going to look at a question they've given us. They've given us f at x is equal to 2x squared plus 12x. Now I look at this through my factoring. What's the first type of factoring I should always do? Do you remember? Factor, yeah. FOIL's the opposite. FOIL is expanding and simplifying. Greatest common factor. So I'm going to look. Is there a common term I can divide both of these by? Plus 2. Yeah, I can divide both the coefficients by 2. And how about the variables? X. So I can divide each of these by 2x, okay? So now I have 2x on the outside, and inside the brackets I have what? X plus 6. There's our factored form, okay? So now this says express each quadratic function in factored form. So we've just gone from standard form to factored form, okay? I know this isn't an x minus r x minus s. That's because we didn't use a specific style of factoring. We only needed the common factor. It says determine the zeros. So essentially this question is f at x, right? Now when we, okay, so when we go to refer this to the graph, and we've quickly just written our objective and our formulas here. Our objective is to change standard to factored form, and standard and factored form are there. Okay. Now it's important to remember f at x, when we're going to graph it, is the equivalent of y, correct? So we have y is equal to 2x, x plus 6, okay? So our y essentially is talking about our y-axis, and our x is our x-axis. The question is asked us to determine the zeros. Zeros are when an equation passes the x-axis, okay? In other words, they're known as x-intercepts. Have you heard of that before? Okay. So they want us to find x-intercepts. Now, luckily, x-intercepts, we already know what one of the values is. Whatever the x-intercepts are, okay, we'll be looking for the x value. We'll know what the y value is. And do you know what the y value is when we're crossing the x-axis? What is y equal to when we cross this line? What's our y value always? Right here. 0. So all of our x-intercepts will always be at y is equivalent of 0. So if they ask us to find the zeros or the roots or the x-intercepts, it has several different names. I can quickly write them out. So x-intercepts, zeros, or roots. Sorry, this is kind of going on our graph. Try to write it out there. That's called finding a y or x-intercept. So what I can do is I can replace the y in this equation with the number 0. So the equation now reads, I'm going to write it down here, 0 is equal to 2x times x plus 6. Now, in order to get 0 in an equation, we have two terms here, 2x times another term. Okay? In order to get 0, one of these has to essentially be 0. We don't know which one, so we're going to assume it could be both. So I have to solve for when this term is equal to 0 and this term is equal to 0. So in order to do that, I split this into two equations. Okay? My equations are 2x is equal to 0 and x plus 6 is equal to 0. Okay? Now I solve for x in each. To isolate x in the first one, I would divide both sides by 2. What would x equal in that case? 0 divided by 2 is 0 divided by anything? We'll check it out here, right? 0 divided by 2, 0. 8, oh, sorry. Clear. 0 divided by 8, 0. All those answers will be 0. So x is 0. In our other case, when we move 6 to the other side of the equation, what will we get? Well, if I'm going to move this 6 to this side of the equation, it's a positive number. It becomes negative. So I get 0 minus 6, which is x is equal to negative 6. So what they're saying is our two, remember what we were trying to solve there were our x-intercepts. Okay, our x-intercepts are my x value is 0 and my y value is 0. So that's one of them, because we know we're going to find 2 because we split into two equations. And the other one is at -6 and 0. So let's quickly relate this to a graph. Okay, we have, let's go by 2s. Okay, -2, -4, -6, -8, and 2, 4, 6, 8. We go to graph this. One of the x-intercepts is at 0 and 0, so that's the origin. I know it's going to cross there. And the other one's at -6 and 0, which is here. So I'm going to have some quadratic function. I don't know if it's opening up or down. Maybe it's like that. Or maybe it's going this way. Okay. Let's try to figure that out in our next steps. Now the next part of the question says to find the vertex of the equation. Okay. So I'm going to do this on the next page. So the next thing we're trying to find is our vertex. Now, there's technically a step in between. Before I find my vertex, I'm going to find my axis of symmetry, it's called. Axis of symmetry. Okay. And in order to find axis of symmetry, I take my two x-intercepts. Those are my r and s values, okay? And this is the formula, it's called. You take r plus s divided by 2, and that will give you your axis of symmetry. We'll call it AOS, okay? The axis of symmetry. Now, our r and s values are going to be the x values of our x-intercepts. So here's r and here's s. It doesn't matter which you name r or s. You just choose, okay? You'll still get the same answer. So our first r value is 0, and our s value is -6. So we're going to plug those into the equation, okay? R was 0 plus -6 is equal, divided by 2 is equal to our axis of symmetry, our AOS. Okay. So what is 0 plus -6? -6 over 2, which is equal to what? -3. So our axis of symmetry, our AOS, is equal to -3. Okay. And what that means is that on the x value of -3, we're going to go back here. At -3 on this graph, that's the dead middle of the parabola we're going to draw. Okay? So axis of symmetry is a straight line going down there. That's the middle of it, at -3. Okay? We know that's our axis of symmetry. What's special about the axis of symmetry is it's also the x value of our vertex. Okay? So now what I've discovered is my vertex, we have to have an x and a y value. The x value is -3. I just have to find my y value now. Okay? Now in order to do that, I take my -3 and I plug it into either the standard form for x or the factored form for x. Either one will work. And what we'll do is we'll do it into both, just so you can see. Okay? I'm going to scroll down a bit and split this page. We had our standard. Both give us the same answer. Our standard was y was equal to 2x squared plus 12x. And our factored was y was equal to 2x times 6 plus, or x plus 6, right? And there's our factored. What we've discovered is our axis of symmetry, x is equal to -3. So for all of the x values, I'm going to plug the number -3 in. Okay? So we're going to get y is equal to 2 times, y is equal to 2 times -3. So we plug -3 into all of these. Okay? I'll solve the standard form first. It's equal to -3 squared is 9. Okay? And then I'm going to multiply by 2. 18. Okay. So we get 18 and -3. Yeah, exactly. Times 12 is -36. So we're going to be subtracting 36. And finally, 18 minus 36, negative 18. Okay. So our y value is negative 18, according to this. Just going to double check with my factor form. Y is equal to 2 times negative 3 is negative 6. Negative 3 plus 6 is going to be what? Not negative, but positive, because the 6 is larger, right? Think of it like this. Negative 3 plus 6, positive 3. Negative 6 times 3? Got the exact same answer. Okay. So what we've discovered now, this is important, is our vertex. Okay? It's at negative 3 and 18. So the vertex of a parabola, go back to put it in. Negative 3, oh sorry, negative 3 and negative 18, correct? Did I write it in wrong? Let me just double check. Oh no, negative 18, I just said it. It's going to be at negative 3, and we're just going to say this is negative 18 for argument's sake. I know it's not perfectly to scale, right? We're going to say that's negative 18. But yeah, we know it's going to open upwards now, our parabola. Our parabola goes like this. So we've now found the zeros. The equation of the axis of symmetry, which is x equals negative 3. That's our AOS is x equals negative 3. Okay, that's the equation, x equals negative 3. And the coordinates of the vertex, which we found at negative 3 and negative 18. We know that that point was 0 and 0, and this point was negative 6 and 0. So we found a lot of information from this. So that's everything we just did in 2 pages. Okay, so we've written our axis of symmetry formula on there. There's one last thing I would like to do. We found x-intercepts, but there is another type of intercept, which is our y-intercept. We want to find when this equation crosses the y-axis. Now the easiest way to do this is to work with our standard form. Standard form, the equation read f of x, or we're going to use it as y because we're talking about graphing right now, is equal to 2x squared plus 12x. Okay. Now, a y-intercept we already know one of the values of that also. What's the x value on the y-axis? What is x equal to? 0, that's right. So our y-intercept is when x is 0, and we're solving for the y value. So in other words, we'll be replacing the x's in the equation with the number 0 and solving for y. So y is equal to 2 times 0 squared plus 12 times 0. What will both of those equal? 0. So what is our y going to equal? 0. So according to this, our y-intercept is at 0 and 0, which makes perfect sense because just so happened it was also one of our x-intercepts. So that worked out perfect for us. Okay. I want you to try that on yours too. So we found our y-intercept also. Okay, in the next example we're going to go from factor to standard form, which is a reversal. Okay. This time we'll do with a harder question. Okay, I'm going to do with C3 which states f at x is equal to 2 times x minus 4 times 3x plus 2. Okay. All they want us to do is move from factor to standard form. So right now we are in the factored form. In order to go to standard form, do you know what we would use here? Foil, that's right. We're going to use our foil. Okay, put it on the outside here. We're going to use foil to go back the other way. So before I multiply this 2, or in other words distribute it, I'm actually going to work with just the brackets. Which makes sense because in BEDMAS we want to work with brackets first. So we're just going to do that to start. We'll keep the 2 on the outside. It'll be easier for us to organize. When I multiply my first terms, okay, what is x times 3x? Outside terms, x times positive 2. Yep. inside terms, negative 4 and 3x. And finally, negative 4 and 2. Yeah, perfect. I'm going to simplify my brackets. So I get 3x squared. 2x plus 12x? Minus 8. All three of these are not like terms, right? I can't do anything with them. But I do have this 2. Now it's important this 2 gets distributed to every number in the brackets. Okay. So essentially we're now going to get 2 times 3x squared is 2 times negative 10x, and negative 8 times 2, and that's it. We're now in our standard